Hassler here. I'm going to work through the 7-8 Explore and give you some notes. We're going to be talking about something called the quadratic formula. And so today we're going to solve quadratic equations using two methods, factoring, which we've done before, and the quadratic formula, which will be something new. In the end, you will decide on your favorite. And so you can see that I have this interesting looking formula up here in the upper corner. And that is our quadratic formula. This is used to help us find solutions to quadratic equations, x-intercepts to quadratic functions. And so we're going to see how this works. One says solve each equation by factoring and then by using the quadratic formula. Remember that the general form of a quadratic is y equals ax squared plus bx plus c. I'm going to box that off. And then make a sketch of your function. So when I see this word solve means that I need to find x. Okay, so to solve an equation, I'm finding a value for x. And so I have 0 equals x squared plus 8x plus 12. There's an equal bar, which means I have to solve or find an answer for x. And so I'm going to do this one by factoring. And so I need to keep that 0 equals because I'm solving an equation. And factoring means that I'm going to break this apart into those two groups. So x squared is broken into x and x. I need factors of 12 that add up to 8. Let's see, there's 1 and 12, 2 and 6, 3 and 4. I think it's going to be 2 and 6. And because this is a plus 12, they need to be the same sign. And because I'm adding to a positive 8, they both need to be pluses. So I got plus 2 and plus 6. I'm going to do a quick check. 2 times 6 is 12. And then I get a 2x. And that x gets paired with the 6, so I get a 6x. And so, yeah, when I add those together, I get 8x. So this works. But remember that I'm finding x. And so I got to figure out what is it going to take for x plus 2 to be 0? Or what is it going to take for x plus 6 to be 0? Right? In other words, remember that 0 times any number is 0. I'm looking for two numbers that multiply to 0. And so x would either have to be -2 or x would have to be -6. Okay, so I found the solution. If I substitute -2 into this equation or -6 into this equation, I would get 0. Now, I have something called the quadratic formula. And the quadratic formula should give me the same answers to the solution. But in order to use the quadratic formula, I noticed that I need to know what the a, the b, and the c are. So if you recall, a is the coefficient of x squared. So in this case, that coefficient is 1. So I'm going to just make a note to myself over here that a is 1. And b is the coefficient of x, and so that would be the plus 8. So b is 8. And c is the constant, and that would be the plus 12. So c equals 12. Okay. And based on this formula, I need to put these numbers, 1, 8, and 12, in the correct spots for a, b, and c. So this first formula I have already set up for you. The formula says -b, and so negative, in these parentheses, I'm going to say 8. And then it says plus or minus, and we'll talk about that in a second. Square root of b squared, so 8 again, minus 4 times a, so 1, times c, so 12. Everything is divided. Look, this giant fraction bar divided by 2 times a, so 2 times 1. Okay, so a couple comments. One, I have this plus minus. Think about the fact that we ended up with 2 answers when we factored. And I'm telling you that the quadratic formula should give us the same 2 answers. So this plus minus means that I'm going to be writing 2 equations, one with a plus and one with a minus. This is a lot to calculate, and so I like to calculate parts at a time. I like to calculate this square root number first, and I like to do that using Desmos, and so I'm going to show you how to do that. Let's go over our Desmos calculator, and on the Desmos calculator, we have this keypad, and so we're going to calculate the square root. So we're going to say square root, we click the square root key. And then we have 8 squared, so I got parentheses 8 squared. And then we have minus 4 times 1 times 12. And notice I haven't even hit enter yet, and it already has, equals 4, but you can hit enter, just bumps you to the next line. Okay, so that square root, whatever's under that square root, when I calculate the square root of that number, I get 4. Okay, so again, I need to split this into two equations. Sorry. And so I'm going to have x equals -8 plus 4, all divided by 2 times 1, which is 2, and x equals -8 minus 4, all divided by 2. Okay, now from here, a lot of you guys can just do this mental calculation, right? If I calculate this, I get -8 plus 4, which is really -4, divided by 2, which is really -2. Oh, hey, that matches. And over here, if I calculate this, I get x equals -12 divided by 2, which is really -6. Oh, hey, that equals. Okay, that matches. And so, yay, using this quadratic formula, I get that, correct answer. So this is great. The other thing it says to do is to sketch. So what I actually want to do is I want to come back up, and this is already set equal to 0. So I'm going to go ahead and type that equation, that standard form quadratic, into Desmos. And so we can just type that in as x. Oops. There we go. We can type that in as x squared. Oops. Got to start a new line, though. There we go. Sorry about that. X squared plus 8x plus 12. And when I look at this graph, I notice that I have x-intercepts at -6 and x-intercepts at -2, which were the solutions when we factored and the solutions when we used that quadratic formula. Okay, and so what I'm going to do is I'm going to come over here and I'm going to say, okay, well, I need to sketch this. And we had an x-intercept at -6, and we had an x-intercept at -2, and then our graph opened up. Now, my question to you is, how can I tell that my graph is going to open up without actually graphing it, right? And so if you recall, if this a value is positive, if the number in front of x squared is positive, I open up. If the number in front of x squared is negative, that's where we reflect and open down. So I'm just going to make a note that we open up. And because we open up because that 8 value is positive. Finally, it says, what do these values represent on the graph of a quadratic function? These values are the x-intercepts. Okay. So I have another one here for you. And in fact, I'm going to let you try that one on your own. I'll post my answer key so that you can check it. It's similar. It's already set equal to 0. And so I don't want to run through this example. What I'm actually going to do is go to the next page. So go to the next page with me. And I want to run through this example because I noticed that this is not set equal to 0. And so I have to do that before I can use either the factoring or quadratic formula method. Okay, so let's talk about C. I want to set equal to 0 first. So that's like a note to myself. I have to set equal to 0. And in order to do that, I would have to subtract 5 from both sides. Okay, and when I do that, I get -2x squared minus 10x minus 8 equals 0. Now, the other thing that I notice here is that I have this -2 as my coefficient of x squared, or as my a value, but we haven't factored any like that. What we have done is factoring out a GCF first, right? And so my GCF would be that a value, that -2. And so if I divide each of these through by -2, I would have that -2 out front, and then I would have a 1x squared, a plus 5x, and a plus 4 left over. And now I can factor. So -2, and then I have my two groups. I need factors of 4. Factors of 4 that are going to add up to 5. So that'd be 1 and 5. And so if I try to find x values that would make this 0, I don't want to be in the way of my graph, I would get x equals -1, because there's only an x here to replace, and I would get x equals -5. because there's only an x here to replace. So I don't even need to worry about that when it comes to solving. And now I want to use the quadratic formula, and I want to use that quadratic formula to hopefully get the same answers. So without peeking on the other side, I'm going to set this up. I've got x equals negative b, so I'm going to put parentheses there, plus or minus the square root of parentheses b squared minus 4ac, so I got parentheses there, all divided, giant fraction bar, by 2a. So notice that I'm actually filling this out with my parentheses first so that I can just drop my numbers, the right a's, b's, and c's, into the correct spot. And we pick our a's, b's, and c's. We're going to pick that from this original function right here. Once I'm set equal to 0, I want to use the a's, b's, and c's from that standard form. So my a is negative 2, my b is negative 10, and my c is negative 8. Oh my goodness, I'm so sorry. I'm just now looking back at my answers and I'm thinking this can't be right. This had to have been 4. I apologize. So this should be 4, so this should be negative 4. Okay. Whew. Hopefully if you were in the room with me, you would have been like, Hassler, that's not right. Okay, so now I got my a's, b's, and c's. So negative b. Now notice that I have the negative for the formula, but I also have a negative for my b value. So negative 10, okay? And then here I have negative 10 squared. So that's in parentheses, the negative 10 part is, okay? Minus 4a, so that's negative 2. C, which is negative 8, all over 2 times a, which is negative 2. All right, so again, I'm going to go over to Desmos, and I'm going to type in the square root information. I want to know what the square root of stuff is. So let's come over here to Desmos. I'm going to clear this out. And I'm going to clear this out and this. Okay. And so I'm going to bring this up. All right, so we have the square root of, and this has to be in parentheses. If this negative 10 is not in parentheses, then when you go to do negative 10 squared, you would get negative 100. If it's in parentheses, then negative 10 times negative 10 gives me a positive 100. Okay, so we need that to be in parentheses. Minus 4 times a, which was negative 2, times c, which was negative 8. And we get 6. Okay. So we're going to come back over here and we're going to say, okay, all of that was equal to 6. So now I have 2 equations. X equals, well, negative 10 is really positive 10. So I got a positive 10 plus 6, all divided by negative 4. And I have positive 10 minus 6, all divided by negative 4. Now, last time we just used our brain to calculate, and I could do that here as well. But I want to show you, if you type this into Desmos, what you have to do. If you type this into your calculator, if you type this into Desmos, you must put parentheses around the numerators, or else your calculator or your Desmos is not going to compute these in the order that you want them to. Like if I do this mentally, I'm adding 10 and 6 together first. So using parentheses tells my calculator, okay, do 10 and 6 first. All right, and so that means in parentheses, I would have 10 plus 6, and then I can hit divide by negative 4. And when I do that, notice that I get this fraction form, which is what my paper looks like. But the only way I'm going to get that fraction form is if I group the 10 and 6 together. Same thing in your calculator. You want your calculator to add the 10 and 6 together first, like you would mentally, and then divide by that negative 4, okay? And then same thing, you could do parentheses 10 minus 6, and then divided by negative 4. And so I get negative 4 and negative 1, which matches what we had before. So this would equal negative 4, and this one equal negative 1, which matches the answers that we have here. Finally, I want to graph this, and so I'm going to type into here I'm going to type in the negative 2x squared. And then we have the minus 10x, and then we have the minus 8. And I notice that my x-intercepts are -4 and -1. I also noticed that this parabola opens down, and the reason it opens down is because that a value is negative, and so this parabola got reflected or turned upside down. And so those are a couple comments that I want to make for our notes here. So the first thing we want to do is say, hey, at -1 and -4, I have x-intercepts, and I have this parabola that opens upside down. And then I just want to make a note here that we open down. And we're opening down because a is negative. All right, so question 4 says, we can solve quadratics algebraically by factoring or using the quadratic formula. And which method do you prefer to use and why? And that's really a personal question. I will say, though, that you cannot factor everything. So factoring does not always work. But quadratic formula does. And so you might like factoring better. I often like factoring better if they're easy to factor, but it doesn't always work. Quadratic formula will always work. So let's just get a couple quick notes down here. The first thing that I want to remind you of is standard form. And so standard form of a quadratic looks like y equals ax squared plus bx plus c. And if I'm finding the x-intercepts, we replace y with 0. So we would have 0x squared plus bx plus c when we're looking for those x-intercepts. And so the next thing, oh no, I just cleared that all out. I'm so sorry. And I don't know how to go back to get that all back. And so I apologize. You are going to have to pause and go back and grab that information. We're going to find solutions. So if we're asked to find solutions, what that means is that we're finding x-intercepts, or we might be finding zeros where the function is 0. And so a couple ways that we can do that is we can factor. But like I said, that doesn't always work. And we can use the quadratic formula. But the only way that I'm allowed to do either of those two things is if I'm set equal to 0 first, okay? And so a reminder, this quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we're going to split that up into two parts. We're going to say, well, that's really negative b plus whatever that square root stuff is divided by 2a, or negative b minus whatever that square root stuff is divided by 2a. So calculating whatever this number is and adding and subtracting that from the negative b all over 2a. The final thing that I want to write, and I'm kind of out of room down here, so I'm just going to write it up here. We're going to say if the a is positive, so greater than 0. If a is positive, then the graph opens up. And if a is negative, then the graph opens down. So just a reminder. Okay, so your job is to give the Check Your Understanding a try. You have 2 problems that you're going to work through, and then we will work through the 7.8 practice in class. If you have questions, let me know.